Okay, so I'm going to talk today actually about some, I was going to say really recent work, but some of it we are implementing at the moment, so recent is not the right term. It is ongoing. I haven't talked about all of this work before, so I'm hoping it comes in order that makes sense to you all. I've been living with this for 5 years, so it makes perfect sense to me, or total insanity, one or the other. But I wanted to talk about different ways that we're thinking about understanding and supporting collaboration in classrooms. So to give you background, I'm going to give you some project background to showcase the sort of 5 years of work and highlight where I'm going to talk about. I'm going to talk about data from typical classroom activities, then what we're doing of clip coding and trying to understand temporal patterns of interaction. Then this piece using log file analysis to support teacher interventions, and I'll talk about conclusions and next steps. And I must say, my association with learning analytics in those fields is my incredible collaborators rather than anything I do. So I might talk about the magic that they make happen, which is sometimes the extent of my understanding of it all. Okay, so a little bit of project background. This work is based on 2 NSF design-based implementation research projects. Back when cyber learning was a more robust program, we've got an initial exploratory grant in 2014, which was for 3 years, and then in 2016 we got a 4-year development and implementation grant to follow up. So the way this program at NSF was meant to work, so you got an exploratory grant, you got some money to start something, and then they gave you more money to push it forwards. I call this a design-based implementation research project, with the caveat that this is an ongoing, moving process, and sometimes this feels way more like just a plain design-based research project with less implementation piece to it. And if people are interested, I'm happy to talk about how the issues and the good and the bad of doing DVIR, and so the acknowledgement that it is not a process that is always sustainable all the time through these multiple year projects. So we're working with 3 large required courses in the College of Engineering. These are gatekeeping courses. They're required for all but computer engineering, all our different engineering programs, and they enroll about 1,000 students a year, 650 in one semester and 350 kids in the other. So they're, from my point of view, they're enormous. The logistics of them, they have more TAs than I have students in my classes. So the logistics of these classes blow my mind at times. In 2012, the College of Engineering actually started this process of pedagogic reform across many of their introductory courses, many of their courses across the whole program, really seeing that there are these issues, female and minority students not persisting beyond some of these gatekeeping courses, and just sort of recognizing that while engineering in Illinois is well known for its innovative research, they really also want to be on the cutting edge of pedagogy. And so this is an incredibly fortuitous time to come into a research project, and we started talking to some of the engineering faculty as we were working on the proposals. And they were identifying some of these issues that they were having as they were implementing collaborative problem solving into their discussion sections. So what had historically been a discussion section where a teaching assistant would come and solve an equation on the blackboard for 50 minutes and the people would take notes, they switched these to collaborative problem-based activities, and identified one of the issues that emerged was that kids really weren't creating joint representations. They weren't actually creating representations at all. And when you're doing introductory engineering, you want to be drawing a free body diagram, working out what part of the diagram matters for your solution, and then applying the solution. And this process of going straight to the equation instead of drawing first, which when I was in grad school, I used to have this big sign up on my desk when I was doing statistics that said, draw first. If you draw, you will understand it in ways that you won't understand it if you just go straight to the equations. And so this was the same problem they were having. The undergrads want to use their equations. They don't want to draw. They don't really want to talk to each other a whole lot. And so we started asking these questions: how can we use technology to give them some incentive to create joint representations, to make it easier to create joint representations? So this process began in these courses in 2012, and it's a series of 3 courses. They'd been implementing collaborative problem solving in the later 2 courses. In 2014, right when this grant was funded, they just started putting collaborative learning into the class that we were data collecting in. So it was incredibly perfect timing to get at the sort of baseline understanding of what was happening in their classrooms, and then work with the faculty to sort of identify problems and change different parts of the project. So what was initially funded as a technology project expanded into task design, TA training, faculty consultation, can take over your life if you let it kind of project. But definitely moving more and more into the sort of idea of DBIR, where you're actually working very closely with the people who are implementing your technology and thinking about the whole context within which they're learning. Okay, so our main research questions on this started off with how can we support students to create joint representations and engage in co-construction of knowledge? And sort of a sub-question to that was, does type of technology influence interactions? So when I started this work, I'd been doing a lot of work previously on large multi-touch tables, so 55-inch iPads, if you haven't got to play with any of them. I started this work before there were iPads, actually, which is, we used to actually have to explain what touchscreens were. But the work from that really did show that having a large shared display was really helpful for students creating a joint representation. This technology is ridiculously expensive still, and not something that we have a huge amount of, we don't have a lot of uses for it yet. Trying to persuade a school or a university that they need to buy a whole lot of these when they can use one or two things on them, one or two apps, is sort of not going to happen. So we wanted to see if it differed if students were using tablets, and what we ended up developing was synchronized software so that if four students are in a group and they each have a tablet, their tablets are synchronized within the group, so I draw my tablet, it shows up on the other people in my group, to see what differences these made for different interaction quality. So then we got into these later questions. How can we help teaching assistants make decisions about when and how to intervene in the groups? As we spent time in the classrooms, this became a clear issue. And then can we help teaching assistants gain a better understanding of how to evaluate collaborative interactions? Which were both issues that sort of emerged as we started to do this work. So the project timeline on this. Year one, we did baseline data collection on classroom practices, and I'll show a little bit of that data, which inspires a lot of the work that came after it. As I said, relationship development with TAs and faculty, and the development of collaborative software. So we spent time developing the synced software that we could use on tablets and multi-touch tables. Year two, we implemented the software in groups of students using tablets, using individual tablets, synchronized tablets, and multi-touch tables, doing sort of three-way comparison. We actually got brought in to do some TA training sessions. I taught for 2 semesters every week to think about how can we actually really support TAs. We started working on task development and outlining sort of methods for how to create good, authentic, collaborative tasks, and then continue to attend their faculty meetings. One of the nice things about the pedagogic reform that was going on was all the faculty who taught in these 3 courses met every week to discuss their pedagogy. This happens so rarely in the kind of context that we were in that we sort of have to take advantage of it. And the faculty, over time, really trying to understand what they were trying to achieve and how we could make changes in their courses. So year 3, we implemented the software just on synchronized tablets and multi-touch tables. Unsurprisingly, individual tablets do not help with creating joint representations. We put it in there to do the baseline comparison. And then this year 3 is the overlapping year between the 2 projects. So we started doing log file analysis and simple video coding of tablets. And the log file analysis of the log files generated when students are using tablets. In year 4, we again implemented the software with groups just using synchronized tablets with a basic TA dashboard that I will show you later. And from this data, we've been doing log file analysis and more complex video coding, and then temporal representations of interaction states. So these are the 2 data sources that I'm really going to focus on today. In year 5, which is right now, our current study, which we are doing on Mondays, we are implementing software on synchronized tablets, and hopefully in about 10 days' time, giving the TAs live prompts based on the log file analysis. So yeah, I'm about 2 weeks early to give you the hey, it works or it doesn't work, but we'll get there. Okay, so what is collaborative learning? To anyone who, I feel like everyone in this room probably is on board with this, but how I define collaborative learning in this context is requiring students to co-construct knowledge and engage in authentic problem-solving activities. It's not merely solving a problem in a group that an individual student could solve, or that a student can divide up among the group members and do separately. Now, there are parts of some of the tasks that we do. Solving equations are kind of the sort of thing that often one student just solves, but they need to work together to get to the point to solve the equation. And so moving in and out of the collaborative space is also something that we've been thinking about a lot in these kind of activities. Why collaborative learning? Also, I'm pretty sure you're all on board with this. But it's been shown to increase learning and transfer of content to new materials, certainly in some contexts. It's been shown to increase persistence of minorities and females in STEM fields, which is particularly of interest to us in engineering. And then there's this need to prepare students to engage in collaborative problem solving when they enter the workforce. And this has become a really key topic as we've been talking to the students about why on earth we're making them have this miserable experience every week. They can do their homeworks, they can do the quizzes, and then we make them come and talk about the work and explain how things fit together and why the equation solves the problem. And it's hard, but it's like, well, it's kind of what you need to do when you graduate. You need to be able to talk about the content. It's not enough to be able to solve the problem in the back of the book. And so this is, and you know, the American ABET, what does it stand for? The accrediting board requires collaboration. Industry requires people to be able to collaborate. So we really want to see that our students get better at collaborating. I have retitled this slide about 16 times. What makes collaborative learning successful? How should we design for computer-supported collaborative learning? Are the two fighting titles right now. This is really just background, and I know I shared with you the paper Marcela Borge and I wrote for ICLS that we're working on expanding at the moment. But this is work I did with Steve Higgins in the UK, where we were looking at multi-touch tables in a classroom context and thinking it's not enough to just design for the technology and the students, and the teams of students. You also have to think about how the teacher fits in, how the teacher relates to the teams, to the technology, and how the different tasks might play out. Which at the time when we first started working on this, I was thinking very disciplinary specific tasks, so contrasting how kids worked in history tasks versus how kids worked in math tasks. But as I've been working with these engineering students, designing and redesigning the tasks and the prompts and the supports that we give them, the role of tasks matters so much in how your technology will actually play out over time. And then teachers, when we talk about collaborative learning, the role of the teachers has been massively understudied. In 2009, Noreen Webb wrote a paper identifying this as a huge issue. There's very limited research on the role of the teacher in collaborative learning classrooms. And so we've seen emergent work in the last 10 years, but it's still not nearly equal to what we see in terms of the amount of work that's been done on collaborative learning. What is the role of the teacher? And when you ask teachers, like, a lot of the times they're like, well, what should I be doing in a classroom? How should I be supporting my groups? And we don't have a huge amount of research on this. We know from work in elementary schools that high levels of monitoring by the teachers is associated with better group outcomes. In a paper that has some interesting confounds, we know that process-focused intervention is better than content-focused intervention. I would caveat this paper that I feel like the research team were giving process-focused and the teachers were giving content-focused interventions, so there are questions here about how applicable that is across the board, but the distinction I think is really important. And then some earlier Webb's work where she pointed out that the wrong type of intervention can disrupt collaborative processes. And I have lots and lots of data to support this particular claim. It's very easy for a teacher to go in and disrupt a group that's doing well, sort of push them off task, or have them go off and decide that what's on their phone is more interesting after the teacher leaves. Okay. So what happens in a typical collaborative learning classroom? This is actually the classroom that we were working in the first year of this project. It was set up as a standard rows of tablet tables, slanted tablet tables, possibly about the worst thing you could give students when you ask them to work in groups. We know from people like Stacey Scott's work on territoriality on tables and games that people don't reach into what's very clearly someone else's space, and a slanted table is very clearly mine. So it makes it difficult for them to even have a space to create a joint representation. This was the classroom that we were in. I feel like there was about 15 discussion sections. This was a 650 students semester, 45 students per discussion section. We were in 4 groups. We were in 5 discussion sections. We videotaped 4 groups. We were actually there the whole semester. In weeks 7 to 10, we persuaded them that in the discussion sections we were videotaping, they should leave the group membership stable So before that, they were changing up the groups every single week. They'd been advised to do this by other departments. It does stop a group, someone being stuck with a bad group. It also means they don't feel comfortable, which was sort of, they didn't really want students to feel comfortable, which was like, well, actually we really do want students to feel comfortable. That's one of the reasons we do collaborative learning is they actually get to know, like even a class of 45, you can be in a different configuration constantly. I haven't done the math on it, but you can end up with different people. They were just giving them numbers as they came into the classroom. So mixing the groups up, students weren't getting to know each other. So we actually compared the 5 sections we were in to the other 8 to 10 sections. And after this, they actually went to stable groups for all 3 classes, all semester long, because it really does help the students. So we ended up with 7 groups that remain. I said 7 stable groups in this slide. I meant 7 consistent groups, 7 groups where all 4 members showed up every week of the 4 weeks. 9 a.m. on Friday is not the time to collect data in an undergraduate.
You said they weren't necessarily stable, was that
They were not. All the groups were theoretically stable. It was the same students in every group, but they definitely consistent. They showed up every week. And there were 6 teaching assistants. There were 2 of them per class, and there were various configurations of the pairs of teaching assistants. So the numbers don't quite work out, but they taught in multiple classes. And then we've transcribed and coded this video in a sort of very traditional turn by turn. Each speaker's turn is transcribed in a play script manner and then coded for the type of interaction. So let me show you this interaction data. When I code interactions, this is a coding scheme I've used a lot. We code for how the statement responds to what came before it. So an independent statement is unrelated to what came before it. The work I did in the UK with 9 to 11-year-olds, we saw a whole lot of this. You see a lot of it in groups where students want to say that their thing, and so want to hold on to it so much that they don't respond to whatever came next. You need a certain amount of this in any conversation. Somebody has to bring up a new topic of conversation. So it's not a bad thing. We're seeing here between 10 and 15%. It's not too bad. I saw a lot more of this with my 9 to 11-year-olds. Quasi-interactive statements are statements that respond to what was said, but don't build or elaborate on it. So, yeah, I agree with you. That sounds good. Let's do that. Like, also very necessary. Here we're seeing between 80 and 90% of turns are in that category, which is not what we're hoping for. We then actually code it for 2 other categories, interactive elaboration and interactive negotiation. I've collapsed them into one category here, because otherwise they wouldn't show up on the chart. Elaboration is when you take what the person said before and develop on it, expand on it. Negotiation is when you take what they said before and negotiate the meaning of it. Whether you're disagreeing or agreeing, or disagreeing or expanding it. No, expanding it is elaboration. We get into trouble with these all the time. But basically disagreeing with it in a way that is productive for your group, not just saying, no, I don't agree with you. So here we're seeing almost none to about 8% across the 4 weeks. This is not co-construction of knowledge. These are the items that look like that should be co-construction. So we're not seeing this. This data is not new or interesting in many ways. We don't often get 4 weeks of the same groups. But what it shows is putting students in groups and telling them to work together doesn't mean they'll have a good experience, and it doesn't mean they will get any better at it. There are actually error bars on my green slide. You just can't see them because they're so tight. There's not a whole lot of variability. No one was very good to start with. Nobody got very good. Nobody got any better across the 4 weeks, which is concerning for us when we're putting students in groups so that they learn how to collaborate, because they're not doing it. And then, so we also have this data of, because the TAs are wandering around, there's 2 TAs, 45 groups of 4, so 11 groups in the classroom. The TAs are 11 or 12 groups, so the TAs are walking around, intervening with the groups. So we actually looked at the same data set to see what the TAs did over those 4 weeks. They had 101 interventions. I really wish there was only 100. Anyway, I know it's easier. 99 of these interventions were purely content focused. So just about the task, how to solve the task. In one of these, they talked about content and the collaborative process, and in one, they just talked about the collaborative process. So the TAs are not helping the students get any better at collaboration.
Can I ask a question?
Yeah.
So when you video record them, they know they're video recorded? Do you think that there is any effect of it? Knowing that someone is recording you?
Perhaps. We do it all the time. We actually consented students in all 14 or 15 discussion sections to try and find the sections with the highest percentage of consent for videotaping, and then ended up with like between 95 and 97% agreement across. Like, the ridiculous comfort with being videotaped was astounding to us. It was a long time since I'd videotaped undergrads, and I hadn't realized how much they cared less. In this, if you look at this, where are we gone? This image, I don't know if you can see. That's that video camera pointing to this group. It's pretty obvious in this one that they're being videotaped. Do I think they were not good collaborators because we were videotaping them? No, I think they're like we videotaped a whole lot of groups over the weeks that remained stable. I don't think it makes that much difference. But yes, it definitely observing them makes a difference. Having 2 or 3 researchers in the classroom makes a difference. We had one very upset student at one point who couldn't work out why there were education people in her engineering course, and just like went off to the faculty who was teaching the class to be like, I think I'll make sense of this. And it's like, okay, we will try and help you. So yeah, it changes the dynamics, but they were also collaborating for the first, like they've never had to do this before. This class has never been taught in this way. There was huge pushback from the students that they were told that going to discussion sections was really good, because if you saw the TA solve a problem on the board and you wrote it down carefully, it would help you prepare for the exam. And all of a sudden they're not doing that. And so they were really, really concerned about, and this content is not assessed in the exams. So it was massively concerning, and they didn't like it. They have got way better over the years of being far more comfortable as the culture has changed, and the faculty have learned to talk about it and explain to them why they're engaging in collaborative activities. But yeah, there were many reasons this was miserable. But this is like I think our video cameras were worst part of it, but I don't think they'd have been very much better without it. Okay, but we did identify a range of other issues. The reliance on TAs for teaching is certainly a problem. A lot of the time for this data set in particular, they're PhD students in engineering. They get very, very little support in learning how to teach or learning about collaboration. The task design was an issue. We've done a lot of work over the years with faculty thinking about how to create good tasks and sort of giving them an outline for how to do it. What really is an authentic task rather than what's a story. And then we're continuously ongoing analysis of our tasks. So I've students right now looking at the last set of data that we collected to really try and understand where are the parts of our tasks that students still need more support. We're experimenting at the moment with sort of how much support to give them and how do you taper that off over the course of the semester as they learn to work together. Creation of joint representations is obviously a problem. When we did this work comparing the collaboration on multi-touch tables versus tablets, and I just finished the analysis on this recently, collaboration is better on multi-touch tables than on tablets, on synchronized tablets. One large display is really helpful. The students hated it. This is not the sort of format engineering undergrads want to work on. 9 to 11-year-olds loved the multi-touch tables, but we had so much pushback from the students on having to make their ideas large, having to be that public. So for a number of reasons, and in part because of the log file analysis that we're doing now, we moved away from them, but the students were really, really uncomfortable with multi-touch tables. I think this context is just the wrong one, even though it actually really did lead to more of that sort of co-construction of knowledge that we were looking for. And as I said, student expectations and attitudes. So again, working with faculty over time to get them to be more overt with the students about what the different, why they were doing homeworks, why they were doing quizzes, why they were doing discussion sections, what were all the learning goals for the course. And learning goals don't have to be passing the exam at the end. There are other things that we want you to learn that don't necessarily, there's 1,000 kids every year in these classes, they do Scantron exams at the end because there's 1,000 students, these are not being graded in complex problem solving. So really having them think about, it's okay to learn something that isn't tested. This is not, we have a broader view of what your learning should be like. So these have been ongoing challenges. Okay, but specifically, when we're working with the TAs, they face a number of specific issues First off, not understanding the purpose of collaborative learning. People who end up doing PhDs tend to have really been good at the subject they did their undergrad in. So one of my favorite TAs ever is like, I read the book and I passed the exams, what's with these students? And he was actually a great TA, but he just didn't even understand why they would need, like, engineering clicked with him, and he didn't get why other people might need help talking about it. They don't know what good and bad collaboration looks like. They don't even know how to evaluate what's happening. They don't know when to intervene, and they don't know how to prompt good collaborative interactions. They don't even know what to say, and they sort of, telling people to work in groups. Oh, you need to work with your group. You need to work with your group. Only gets you so far. So as I said, we really briefly taught a TA seminar over 2 semesters. I taught it 1 semester, and then my graduate students took it on the 2nd semester. I'm not going to go into the details. What was really helpful for the TAs, for those who would allow it, was when my students went and sat in their classes and then talked to them afterwards and really gave them that personal experience of how they should be teaching. We also were trying to cover some of these big issues of, why collaborative learning, and then you get into these questions of like, what happens about returning TAs? How many times do they have to take this class? This is actually on my next slide. Who is going to pay for it? Some of my grad students would have really enjoyed their time in the classrooms helping the TAs, but they can't spend their whole lives doing that. They have dissertations to write as well. So, like, where does this fit? They have these weekly weekly TA sessions, which are often focused on logistics, so trying to get more of it into there. But none of this was enough, and we still haven't found the solution for who pays for it and how to keep it ongoing. So the next thought for us was, can we do this while TAs are working in the classroom? Can we create dashboards to support teaching? Building on this first project where students were working on tablets, and this is a group of students working on tablets. I started thinking about using multimodal analysis of videos and log files to identify interaction patterns, so that we're actually giving the TAs live prompts about what's going on. They're getting not the same as having a graduate student sit in their classroom and talk to them about it afterwards, but actually in the moment telling them what's happening in the groups. So this is the data we collected last year, synchronized tablets and simple TA tools. We have 2 teaching assistants and 4 course assistants who are undergraduates who took the class in previous years, 4 discussion sections who met weekly in our lab classroom. They taught using the orchestration tool every week for 14 weeks, and we did observations throughout the semester, and my students did some interviews with the TAs as well throughout the semester. So this is our lab classroom. This is the Illinois Digital Ecologies and Learning Lab. We have ceiling-mounted cameras, hanging microphones, table microphones, and a one-way mirror. The mirror was already there when we decided to use this lab space. It's actually really useful because we sit in the room behind and can watch what's going on. Can solve some of the technical issues without having to go into the room. We can also feed the microphone feeds into the room at the back, so we can listen to groups. We can actually do observations without having to be in the room, and that is very helpful when you want to do. One of my students is looking at the TA use of the tool, so you want to do very quick interviews with them afterwards to see why they did certain things. So she sits there and takes notes during data collection.
How big is that? How many groups?
There are usually 8 groups in this room. I had to cut the picture to get people who have consent for photographs. So there's more. The room officially seats 50, but it's crowded with 50 people in it. And so we have 8 cameras and this fishbowl camera in the middle, so we can capture the whole space. And so we track the TA as they're walking around, and the TAs are mic'd as well and synced to that, so we can see where they're moving about the room. We would love, and Tim and I were talking about this earlier, to do some motion tracking stuff as well, which I think will be interesting later on to see exactly where the TA goes and how they interact with the students. Okay, here's an image of the student tool, which is synced across devices. I'll give you labels on it, which is better. There's different pages of the task, and so here you have the page location. You can see where you are. And everyone in this group is actually on the same page, but you can see each person gets a different color. This is orange. Here's this orange dot. He's right here at the top of the page. And you can see where people have scrolled to on the page, or their dot shows up on a different page if they're actually at a different page location. Again, to raise awareness of the group of what other people are doing. And then they have a set of tools. They can write, they have pens and highlighters, and I realize this is not the most recent version because we do actually, now we're using the same tools that they actually use in their online quizzes, so they can drag and drop arrows and drawing tools. So in the online quizzes, they actually do automatic assessment of their drawings. We're not doing it at this point in time, but it would certainly have potential if we wanted to integrate all of that at some point. But it's the same set of arrows and various things that they need. I can't remember what else is on it right now. So that they can draw the same type of drawings they draw in their assignments. Again, pushing this idea that they need to create representations. And then in this first year, we used the basic TA dashboard. Now this top, I did not like this top image. Everybody asked for it. It shows how much any group is writing on the tablet at any point in time. So this generates as the class moves through. Everybody wanted it. Everybody hated it. So we tried it. We decided to ditch it in the next iteration. In theory, if you spend time looking at it, it's sort of informative, but it's not the sort of visualization that's any use when you have 32 students in the classroom. And then you have these small versions of what the students are working on, and the TA can click on it. They can actually see here each. I don't know if you can see. There's a purple, a yellow, and an orange. So there's 3 people in this group, and they're all on the same page. You can actually see the orange is written twice as much as the yellow and the purple, but they've written about a quarter, and the orange is written half. It's half full. So everybody's.
So each of those panels
is a group.
Sorry.
Oh, each of these panels is a page of their worksheet. So these are the pages of the worksheet, and this is the 3 people and how much they're writing on it. Writing being one measure of contribution, and that's definitely, sometimes one student does all the writing and other people tell them what to write. So it's not always the best measure.
Do they have different colors?
Each student's tablet, each student has a different, no, they're just the top of their sheet has a different color. So it's not, they can pick whatever pen color they want, but you know which.
But it's all the same, right? So a sheet ends up having the same thing on it.
Yes. So it's not the color of their pen; it's the color of their tablet, basically. So this is the tablet screen. So this is the orange student. You can just see it at the top of the screen. We had thought about using names and things like that, but the TAs don't always know the student names. So this is the orange student, and then you can see orange is written half as much. So it's the log file data that's telling you how much the student has written, not anything that you can see on the screen itself. You wouldn't know from looking at the screen who's done the most writing.
Oh, okay.
The TA can open this and enlarge it, and they can actually join the group, write on the tablet, write on what the group are doing if they want to, and also project it to the whiteboard, or to the display, which we would like them to use more at the end of the session to do sort of wrap-up activities, but we don't see a huge amount of that at this point in time. So the data that we used from this, we had 73 unique participants, 18 of them were female. These were drawn from 20 groups, 4 different classes, and we have data from these 73 participants in each of 7 weeks. This is a lot of data. We did video and log file. The video data and the log file data was divided into 20-second clips, so there were a total of 21,000 clips. My students are still talking to me. They coded 16,270 of these. They used a lot of them. They used a lot of them to develop the coding schemes and things like that. And then we extracted 107. Luke and Nigel extracted 107 features from the log files. And then the video analysis and log file data was used to develop predictive models of how groups were collaborating. So to get a little more detail on this, the clips were coded in a variety of different, every 20-second clip was coded for whether or not it was task-related, what the talk content was, whether there was peer interaction, whether there was TA interaction, whether there were issues that emerged, and whether they were using the tablets or not. This allowed us to create group states, so a positive, I clearly got distracted. My notes say positive is, and I didn't fill out what a positive state is, but I do have it up there. A positive state was on task for task related, on task talk, peer interact there is verbal interaction, there's no TA present, there's no issues, and they're using the tablet. Or I'm not sure if using the tablet does not come into this one. So positive state, they're talking to each other and it's a good group. No, there's no problems. Silent, on task, they appear to be working on the task but they're not talking. Other talk, off task, teachers work with the whole class, teachers with the group, or there's issues or problems in the group. So this allows us to start playing with visual representations of the groups over time. This is just drawn from the video coding. So these are two different groups. If we're down here at the bottom line, it's not happening, and if nothing's happening, and if it's at the top line, something's happening. Blue is good, positive states. Yellow is the TA intervention. Light blue, which there's just a couple of these on the top, which I'm not even sure you guys can see, is a problem. And green is the TA talking to the whole group. So this first group here has lots of long stretches of time where they are in a positive state. They're talking to each other, they're on task, a couple of interactions with the TA. This group down here, orange, is actually on task silent. So these are it's groups from the same class, same worksheet, the same activity. This group are on task a lot, but they're not talking to each other very much. So these start pointing to us, like what do different interaction patterns? Let's go look at how much progress the two groups are making on the task, how much they're understanding what's going on. They seem like interesting, contrasting cases that we want to play with. And we can also look at the same group across different weeks. So this is group 6 again, that I just showed you at the top. And this is them in a later week, in week 11, where they have these two big long chunks of TA interaction. In the first one, there's actually a light blue dot. There's one 20-second problem. I'm assuming they put up their hand and the TA came over as soon as the problem emerged. So the TA spends 2 long chunks with this group. In the second there's not a problem, and the TA still spends a lot of time with them. So this is sort of an interesting question, is whether they need TA help, would they have just continued to work on the task without the TA intervention? Because in general, and we look at group 6 across the 5 different weeks of data that we have, and this group is they spend a lot of time in positive state talking to each other about the work. So it's sort of interesting to see in week 11, why did the TA spend so much time with this group? So these patterns allow us to think about how collaboration unfolds over time and what that means from a teaching perspective. I've spent most of my life up to now counting the types of interaction, like how often does quasi-interactive turns show up. So to me, it's kind of interesting, the temporal analysis, which I know people have been doing for a while, but thinking about how do we express to teachers what's going on in a group, how do you make a decision about when you should interrupt? A problem, obviously a positive state followed by a problem state. And can we use examples of this as we're sort of helping teachers and TAs understand what a group looks like when they need help and what a group looks like when they don't need help. And so how do we have a lot of instances of positive states being interrupted by TAs who all come and say, hey, what are you guys up to? Which, we were doing great, and now we have to stop and talk to you, which is not always productive for the group. It lets us identify new patterns to help guide analysis. So week 11 is actually a good week for all the groups. There's these long stretches of positive states. And so as we're sort of thinking about task design and what is it about the tasks that are leading students to engage in collaborative discussion, that seems like a week where we need to go and pick apart the task and see if that's what's going on. Or was it, random other stuff happens as well? Was there something else that led to a good week? And do individual groups change over time? Do we see more of this positive state occurring? And what happens when they don't show up improvement or when the pattern changes? So we have a couple of examples where they seem to be getting better at this over time, and then there's a week where it isn't good. So being able to look at that across all the groups lets us say, well, is this is a really bad task that week, which we still do really bad tasks sometimes, or is there something else going on in the group that may explain what's happening? Okay, so that's what we did with the 20-second codes, just from sort of a much more traditional trying to understand the video. Luke and Nigel decided to extract log file data, and the sort of features that I'm still not sure what all 107 features are. I have listed them somewhere. But the total quantity of actions, so the number of line segments that are drawn, the number of times drawings were selected, you can select and move a drawing around, number of times students undid their last action, everything you can do on a tablet can be recorded like this. the location of the actions, so the horizontal and vertical position of drawings, and then student co-interactions, so the number of different students who are drawing concurrently on the tablet, the differences between the students' scroll positions or even page positions, and the ratio of the least active to the most active students' actions. This is a very small sample of the vast number of things that you can pull from this.
Do the qualitative dimensions make it into the features that went into the machine learning model? So these positive states, the TA interaction states?
Yes, and I'm going to get to that in the next stage. Okay. Yeah, it's the model development. So models were created for every annotation code. So all of our coding, when you work with computer scientists, which I'm guessing most of you know, is they are very good at calling our work annotation codes. So it's different from the coding that they're doing. So on task, peer interaction, no peer interaction, etc. They did all the combinations that you could possibly have of our codes. They used random forest algorithms, and Nigel says, since the type of relationship between the students' collaborative interactions and their actions in the tablet was unknown, so linear or piecewise relationships, they started with random forest since these are flexible enough and tend to work for a variety of data distributions. In the future, he wants to consider more specialized algorithms. So hopefully some of you understood that. Why we picked random forest algorithms. He actually didn't use this the first time we were doing it. But this allows him to sort of say, from the codes that we developed and identified in the video, which features are associated with them. How can the models from the features predict the codes that we had? So these codes were tested using both Cohen's kappa, which many of you will be familiar with, and then AUC, which is area under the receiving operating characteristic curve. And the model was validating using leave one group out cross-validation. So they trained the model in all but one group of the data, and then they tested it on the remaining data set, and kept repeating this until the model had been tested on every group. Don't ask me complicated questions about this. When we look at our results, and I'm not in the right place to click, we have here the results for kappa, where 0 is random chance and 1 is perfect accuracy, and also AUC, where 0.5 is random chance and 1 is perfect accuracy. So these models are not doing too badly. So for AUC on task, we're at 0.926, 0.489 with kappa, which is not, if these were my students coding, I would not be thrilled with them. But for a model, it's not too bad. We are still having trouble with a lot of our models, partly because, despite what it feels like, we don't have enough data. And so some of the models are still, some of these models are still low if you think about Cohen's kappa. Silent, 0.26, it's sort of a standing we can get anywhere above chance on whether or not people are talking. It's 0.72 on AUC. So there are different ways of assessing validity. And then there are other models of things like solo work, which we see a lot, where one student's working on the task and everyone else is off task. Actually, we apparently don't see it a lot. We see it less than 3%. It feels like we see it a lot. Confusion, domination, non-responsiveness, all of these things that we coded for in our coding scheme that we just don't have enough examples of to build appropriate models.
Could you just remind me, I mean, to get on task, what features have to be present? I mean, I don't know what features they're picking out of the log analysis.
Oh, I have no idea. That's a massive, the log files? I have no idea what log file analysis, what the actual model is. And even when I get Nigel to talk about these, he's like, that's the magic going on in the background. He can pull up all the information, but of the 107 features that they extracted, a model, there's a model they use that fits on task that gets to 0.92.
It's some combination of those 107.
Yeah, and because it's not quite that simple because we have 20-second code, so it's like some of these are tested on, did this thing happen in the last 20 seconds or in the last 40 seconds or the last 60 seconds? Like, so there's okay. Also building on top. So.
I'm sorry to persist.
No, please.
This is a big mystery to me. If they take your 20-second code and then they look at that same 20 seconds in the log file, and would they be like saying what features are there in that 20 seconds? Is that how they actually do this? Or, I don't know what the training process is like. And I'm trying to understand how they do going from your 20-second coding to features.
Right. So of the features, I think they start with that question of like which of these features exist in all the codes that are only coded, all the video that's coded as on task.
Okay.
Which of those, and then they expand it
Yeah.
in ways that
Right.
is beyond me and also beyond them.
So the video is coded by some human?
Yep.
Okay.
Yeah,
By people.
my poor unfortunate graduate students, yes.
Hand coding.
Hand coding. And so, and this is the reality of this and why we would never implement this without, like, one thing we talked about early on was like, would you do the awful Microsoft Word clippy thing of actually giving the students direct feedback? No. This needs an adult, I was going to say. This needs a teacher, somebody to actually stand there and make an assessment as to whether or not this is truly happening. We're not at anywhere near the point that I would want to say, hey, you guys aren't on task, when they're on task and our model isn't quite there yet. So yeah, we're not, those things are really annoying, and I don't think we'll ever, no matter how many layers of data we manage to pile on top of this, I think the human judgment is always going to be part of the call. Could be wrong, but I think so. Okay, so our real-time prediction software runs in this continuous loop, applying the models to the data as it comes in to make collaboration predictions. So the students are working in the lab classroom, their data is going directly to the server as we're working on it. I have a picture, actually. Nigel sent me pictures to go with this. So the students are working on their 4 tablets. It's going back to the app server, which is feeding to the prediction server, running the models live, which go back to the app server, and then show up on the TA tablet. We are testing this on Monday. Our model. So it works in theory. It has worked when we run it against old log files that we have collected. We have not actually managed to test it on live classrooms yet. So there's no reason to think it won't work, but anyone who's ever implemented technology in classrooms know that doesn't matter. But yeah, so we've got a couple. The nice thing, by the way, our lab is set up. We will test it in the room behind the one-way mirror for at least one session before we implement it in the classroom. So the TAs, we'll test it before the TAs see it. Okay, so creating prompts. Another group of my students has spent a lot of time coming up with prompts. This is what the TA dashboard looks like now. We took off that really annoying thing. This is from February 18th. This is just from a couple weeks ago. Spring 19. And so this is a live set of data. These classes having groups in it. So exactly the same, they can view the work. I actually realized I don't know what we have settled on to test first to alert the TAs about which group needs intervention. We are going to be testing this a lot over the next few weeks because, does every group get a nice green box around it when everything's fine, and does it turn to yellow or red? Yellow if there's a problem, and then red if you ignore the problem for long enough. Do we make them flash? Do we make them larger? We've thought about this all. We have no idea what's going to be annoying, what's going to be noticeable, where that line between noticeable and annoying is. But then one of these is going to start flashing red and miserable or something, and the TA can click on it and get what we're telling them at the moment is monitor for off task. So we don't know if we think that this is happening. This is what our model is telling us is happening. Go take a look at the group. Monitoring is something we don't see a whole lot of, so we're definitely putting this into the language. Stand and look at what's going on, and then confirm or deny the issue. So this is a data source that we'll be collecting, whether or not we're still collecting video, so we will also be able to go back and see if the model was right, but also did the TA understand it. And if they confirm the issue, they get the prompt to address the group. Again, we've gone back and forth on the content of these tips. We have a huge list of them. How many do you want to give TAs? How complex do you want them to be? Do you want to give it, if we have 6 off-task opportunities during the class time, do we want to give 6 different versions of the prompt, or do we want to give 6? We want to leave the same one 6 times? All things that we're sort of drawing on research and trying to make up as we go along, and really just see what works for the TAs. So thankfully our TAs are both really willing to work with us on this stuff.
Have you thought of having different tips based on what the problem is? So like, if all the students seem to be on different pages or something doing different things, then there would be a different
tip. Yes, tip. So there's different tips based on what we think the problem is.
Okay.
And yeah, right now it is only those 5 or 6 things that we're going to identify as problems. Hopefully, as we get more data, we'll be able to identify more of them. My students have generated masses of lists of different types of tips for all the potential problems that we could identify. But yeah, the tips will be very specific to the issue going on. Okay, so future directions. We are currently implementing this in 5 discussion sections each week. We've done this. It's exhausting and really nice to do these semester-long implementations. Our lab is assigned. They're assigned to classrooms, so the students show up every week. They complain because it's been so cold. They have to walk half a mile to get to it. I kind of don't blame them right now. But they show up. It's their classroom. It's normal. Some weeks we turn the video cameras on. Some weeks we don't. Most of the weeks we do at the moment because I can't help myself. We've done multiple training sessions. We collected the first 2 weeks of data really without any intervention. We just let the TAs do their normal thing. Then we did some training sessions around collaborative learning. And at the moment, possibly literally at the moment, my students are doing some training sessions on how to use the software and what the different tips will mean. And then we'll continuously train them as we start to implement the software. And we have been doing interviews as well with them along the way to try and get whether or not their understanding of collaboration changes with time or with these different interventions. So we'll be analyzing the data, comparing the TAs before and after they use the prompts and the pre and post test interviews, and then analyzing how much sense they're making of the prompts. Are they seeing what we're seeing? Is it matching the video analysis that we'll do later? What prompts made sense to them? What prompts were just useless? Did they implement them the way we intended them to implement them? All those questions are still up for grabs. Next year is going to be busy. Okay, so some conclusions. We've had some success in identifying collaborative behavior from log files. I would not say this is the answer to everything. There's no way I would want to put this into a classroom without our TAs being so willing to work with us and sort of understand that it's an experimental process. It says they're exploring combinations of large and small segments to increase activity. So number of drawings in the last 20 seconds, the last 5 minutes, cumulative over the entire session. All of this takes a ridiculous amount of time and energy on their side, again, to keep pushing on the accuracy of our models. And my next steps are really to explore different data sources, so speech, movement of devices, when people pick up their tablets or move them around, you can tell things. We're looking at speech from microphones, speech from the tablets, and I would love to move this into other content areas too. Engineering is where this work started, but I think thinking about these models in other types of classrooms, engineering students solving these type of problems have a very specific interaction pattern. So what does that look like elsewhere? I don't think these models at this point would necessarily hold in any other content area right now. And thanks to my ridiculously incredible team. These are just brilliant people who make most of this work. And thank you. Any questions would be